Section 2.4 deals with solving higher degree polynomial equations. To solve, you're going to use the same factoring steps that we did in Section 2.3. Remember, you need to get one side equal to 0, you need to factor the other side, and then you'll set each factor equal to 0 and solve the resulting equation. So let's look at this first problem. Factoring out the greatest common factor, that would be x times 6x squared minus 5x minus 4. And then that trinomial could factor further as 3x minus 4 and 2x plus 1. Now, setting all of our factors equal to 0, we now have created 3 linear equations for us to solve. The first one, there's nothing to do. X is equal to 0. The second one, when we add 4 to both sides and divide by 3, we get x is equal to 4/3. And then the last one, moving the 1 to the other side, dividing by 2, we get our third answer, which is x is equal to -1/2. This next one, x to the 4th minus 23x squared plus 90 is equal to 0. Again, it's set equal to 0 for us, so we factor it. Factoring the trinomial, it would be x squared minus 5, x squared minus 18. Now, neither one of those can factor any further, but that's fine. We'll set them both equal to 0, and they are quadratic equations, and we can solve them by some other method. If I take this -5 over to the other side, I can use the square root method, and we would get x is equal to plus or minus the square root of 5. Same thing with the other one. Take the -18 to the other side, take the square root of both sides, and we would get x is equal to plus or minus 3 square roots of 2. 2y to the 4th minus 5y squared minus 12 equals to 0. Again, they've already set it equal to 0 for us, so we can factor it. This would factor as 2y squared minus 3 times y squared plus 4. Neither one of those would factor any further for us, but we can set them both equal to 0 and solve them because they are linear equations. Again, getting the squared term by itself, we would get y squared is equal to 3/2. Using the square root method, we get y is equal to plus or minus. Now, we don't know the square root of 3 and we don't know the square root of 2, but we do know that we cannot have a radical in the denominator. So I'm going to have to rationalize this by multiplying by the square root of 2 on top and bottom. So our final answer would be plus or minus the square root of 6 over 2. On the other side, taking the 4 over, it becomes -4. Again, using the square root method, we'd get y is equal to plus or minus 2i. Now, this next one, if you'll notice, has 4 terms. One of the methods of factoring that you might not remember is that when you have 4 terms, you group. You take the greatest common factor out of the first 2 terms. You take the greatest common factor out of the next 2 terms. And then you take the greatest common factor out of the whole problem. Now, looking at what we have left, that y squared minus 4 can break down further as y plus 2y minus 2. Now that we've got it factored out, we'll set them all equal to 0 and solve. So that would give us y is equal to -1, y is equal to -2, and y is equal to +2. Now, this next one involves our cubes, and if you have not factored in a while with your cubes, you do need to remember your rule for factoring your cubes. We have the difference, so we need to use a to the 3rd minus b to the 3rd is equal to a minus b times a squared plus ab plus b squared. Now, remember, they have to be cubed, so I've got to rewrite the 8 as 2 cubed. And I have to rewrite the 27 as 3 cubed, and we'll use the 2t as our a, the 3 as our b, and plug in. So we would get 2t minus 3 times 4t squared plus 6t plus 9 is equal to 0. Now, this first factor is linear. We can set it equal to 0 and solve it. we would get t is equal to 3 over 2. When you were taught your cube rules for factoring, your teacher should have told you that the trinomial that you get will never factor any further. So I know this trinomial is not going to factor, so I'm going to have to use some other method, and I'll use the quadratic formula. So t would be equal to negative 6 plus or minus the square root of 36 minus 4 times 9 all over 2 times 4. That's going to be negative 6 plus or minus the square root of negative 108 divided by 8, which breaks down as negative 6 plus or minus 6i square root of 3 over 8. Now reducing everything by 2, we would get negative 3 plus or minus 3i square root of 3 all over 4. Now, looking at this next problem, it is not actually what we would call higher degree, but it's more what we call quadratic in form. You're going to want to factor these just like they were quadratics, except we have a 2x to the 2/3 that we need to break down. So that's going to be 2x to the 1/3 and x to the 1/3 when we factor it. Now, making sure our numbers match up, we need a -1 and then a +2, and we'll set each one of these factors equal to 0. Now we need to get the x by itself, so I'll move the 1 over and I'll divide by 2. And we would have x to the 1/3 is equal to 1/2. Now you do need to remember your rational exponents. The 1/3 power is the same thing as the cube root. And the operation that undoes cube roots is cubing. So we need to cube both sides, and we would get x is equal to 1 over 8. Doing that same process on the other side, I'll get the x by itself. Again, this 1/3 power is the cube root, so I need to cube both sides, and we would get x is equal to -8. Same type of problem, quadratic in form. So again, we're going to factor it. It would factor as 3x to the 1/5 minus 1 and x to the 1/5 plus 3. Setting both of those factors equal to 0, we can solve them. We need that x by itself, so I'll add 1 and divide by 3. So we get x to the 1/5 is equal to 1/3. And again, the 1/5 power is the same thing as the 5th root. So to get rid of it, we would need to take both sides to the 5th power. And that's going to give us x is equal to 1 over 243. The other factor, the same thing. Get the x by itself, raise both sides to the 5th power, and we would get x is equal to -243. All right, one more. And if you'll notice here, this is also in quadratic in form, but they have put, instead of just x, is x squared plus 2x that is squared. So the method that they use for Hawks is for us to use substitution. We're going to take another variable, let's call it k, and it's going to be equal to that x squared plus 2x. When I plug that in, I would get k squared minus 7k minus 8 is equal to 0. We're doing this so that we can factor this a little bit easier. Notice when we plug the k's in, it's very easy to factor this. This would be x minus 8 and k minus 8 and k plus 1. Now that we know how to factor it, let's plug those the x squared plus 2x back in for k. So we would have x squared plus 2x minus 8, and then we would have the x squared plus 2x plus 1. Now both of those could factor further. This would be x plus 4, x minus 2. This one would be x plus 1, x plus 1. Now taking all of these factors, setting them equal to 0, we can solve them, and we get x is equal to -4, x is equal to 2, and x is equal to -1. Now notice I did not work that one twice because it is the same.